Hi, welcome to our video lab report on the energy of a spring, brought to you by Davis, Michael, and myself, Haley. So our question was, how does the force and potential energy in a spring relate? We hypothesized that based on the spring force equation, if we compress the spring by a factor of 2, then the resulting force will increase by a factor of 2, and the energy will increase by a factor of 4.
So first of all, let's define the energy and force that we looked at in the lab. So the force that we looked at in the lab is the spring force. The spring force can be defined as negative K times delta X. K is a spring constant, which is different for every spring, and delta X is the displacement of the spring from a resting position to a compressed or stretched position. And then energy would be potential and the change of energy, which is work. This is defined as force times delta X, or the change in potential energy. Well, with F being the spring force and delta X would be the displacement of the spring. So next, let's talk about the design of our experiment. First, we set up the IO lab with the force plate and measured force and position. Then we create a base to set the spring upon, for example, a wooden cube or a box. The next thing is we put the IO Lab's force plate on the spring and compressed it by about 0.005 meters by using a ruler to measure. Then we record the force and then we let decompress. Then we repeat the process by doubling the distance, so 0.01 meters, and record the force, let decompress, rinse and repeat for the other springs.
So here we have our data. And with our data, what we did is for each trial we averaged it out so we could have the average force for each one. And as we looked at this data, we realized that each one was roughly about double. Well, not all of them were perfectly double. It was around that area. And for our potential energy, we used the equation above, going force times delta X to get our energy in joules to see how the energy related. And for each, and we did averaged out the energy that we had for each of the trials, and then here's the average values. And for each one, we found that it doubled, or it increased by about 4 times every time we doubled the distance.
So in conclusion, our data supports our hypothesis that based on the spring force equation, if we compress the spring by a factor of 2, then the resulting force will also increase by a factor of 2, and the energy will increase by a factor of 4.
There were some possible errors and limitations with this lab. One of the limitations was the IO lab's limit for measurement for force, which would have been 21 newtons. So we had to adjust our distances to fit within that range. And then the other limitation was our physical limit for compression. So how much we could have compressed the springs without hurting ourselves.